Download this code from codegive.com, link in the description below. Dockerizing User Stories with Mayfly by Maarten Dirkse, a comprehensive tutorial. This tutorial will guide you through the process of dockerizing user stories using Mayfly, a powerful and lightweight library developed by Maarten Dirkse, specifically designed for simplifying the execution and validation of acceptance tests within Docker containers. What is Mayfly? Mayfly is a minimalist yet effective library written in Python. Its core strength lies in its ability to manage the life cycle of Docker containers during acceptance testing. It allows you to start and stop containers. Mayfly provides a clean and intuitive interface for launching Docker containers before tests and gracefully shutting them down afterward. Execute commands inside containers. You can execute commands directly within the running containers, enabling you to perform setups, configurations, and interact with your application. Verify container state. Mayfly facilitates checks on the running containers, ensuring they are in the desired state before and after running tests. This includes verifying processes are running, files exist, ports are exposed, and logs contain specific messages. Streamline acceptance tests. By automating container management, Mayfly makes your acceptance tests more reliable, repeatable, and easier to integrate into CI/CD pipelines. Why Dockerize user stories? Dockerizing user stories for acceptance testing offers several significant advantages. Reproducibility. Guarantees a consistent and predictable test environment regardless of the underlying infrastructure. Isolation. Isolates test environments, preventing dependencies, conflicts, and ensuring that tests are not affected by external factors. Parallelization. Allows for parallel execution of tests, significantly reducing the overall testing time. CI/CD integration. Enables seamless integration of acceptance tests into continuous integration and continuous deployment pipelines. Version control. Container images can be versioned, providing a history of test environments and facilitating rollbacks. Prerequisites. Docker. Ensure Docker is installed and running on your machine. You can download it from https://www.docker.com/getstarted, https://www.docker.com/get-started. Python. Python 3.6 or later is recommended. Pip. The Python package installer. Step 1. Install Mayfly. First, install Mayfly using pip. Step 2. Define your user story and test scenario. Let's consider a simple user story. User story. As a user, I want to access a web application running in a Docker container and see the message "Hello, world." Test scenario. 1. Start a Docker container running a simple web server. 2. Verify the web server is running and listening on port 80. 3. Send an HTTP request to the web server. 4. Verify the response contains the message "Hello, world." 5. Stop the Docker container. Step 3. Create a simple web application, optional. If you don't already have a web application to test, you can create a very basic one using Python and Flask. This will be packaged into a Docker image later. Step 4. Create a Docker file. Create a Docker file for your web application, if you created one in the previous step. This Docker file will define how to build the container image. Create a requirements.txt file to specify Flask as a dependency. Build the Docker image. Step 5. Write the acceptance test using Mayfly. Now, let's write the Python code that uses Mayfly to automate the acceptance test. We'll use the ptest framework for structuring our test. Explanation *. 1. Imports * import necessary libraries, ptest, Mayfly, requests, and time. 2. Container fixture *. *At ptest.fixture, scope equals module, * this decorator defines a ptest fixture named container. The scope equals module argument ensures that the container is started only once per test module, file. Container _config * this dictionary defines the configuration for the Docker container. Image, the name of the Docker image to use, example my web app. Make sure this matches the name you used when building the image. Ports, a dictionary mapping container ports to host ports. In this case, we're mapping container port 80, where the web server runs, to host port 8080. This allows us to access the web application from the host machine. Wait for ports, a list of ports that Mayfly should wait for to be open within the container before running tests. Ready _test, a lambda function that defines a test to check if the container is ready. It checks that the server is up and responds with a 200 OK. Ready _test _timeout, max seconds to wait for ready _test. With Mayfly, containers equals container _config, as m*. This line uses Mayfly to manage the container's lifecycle. Mayfly, containers equals container _config, creates a Mayfly instance, passing the container configuration. With, as m, this ensures that the container is automatically started when the with block is entered and stopped when the block is exited. M, the Mayfly instance, providing access to the managed containers. M.containers 0, this gets the first, and in this case, only, container managed by Mayfly. It returns a container object that provides methods to interact with the container. Yield M.containers 0, this yields the container object to the test function. The code after yield will be executed after the test function finishes. 3. Test _hello _world, container, test function *. Container argument *. This is the container object yielded by the container fixture. It provides methods to interact with the running container. Time.sleep, 2, added initially to give the application in the container time to start. Replace this with the ready _test as shown above. Response equals requests.get, http://localhost 8080, sends an HTTP GET request to the web application running in the container. Note that we're using localhost 8080 because we map the container's port 80 to the host's port 8080 in the container configuration. Assert response.status _code equals 200, asserts that the HTTP status code of the response is 200, OK. Assert hello, world, in response.text, asserts that the response body contains the string hello, world. Step 6, run the test. Run the test using ptest. Expected output *. You should see output similar to this. If the test passes, it means that 1. The Docker container was successfully started. 2. The web server inside the container is running. 3. The web server returned the expected message. 4. The Docker container was successfully stopped after the test. Advanced usage and customization *. Environment variables * You can set environment variables for the container using the environment key in the container _config. Volumes * You can mount volumes to the container using the volumes key in the container _config. This allows you to share data between the host machine and the container. Asterisk using container object methods. Asterisk the container object provides methods for more advanced interactions. Asterisk container.exec underscore command executes a command inside the container. Returns a tuple, exit underscore code, stout, stare. Asterisk container.logs, gets the logs from the container. Asterisk multiple containers. Asterisk you can manage multiple containers simultaneously by providing a list of container underscore config dictionaries to the Mayfly constructor. This is useful for testing applications that depend on multiple services, example a web application with a database. Asterisk extending Mayfly. Asterisk you can subclass the Mayfly class to customize its behavior. This allows you to add custom setup and teardown logic. Best practices. Asterisk keep container images small. Asterisk use multi-stage builds to create smaller and more efficient container images. Asterisk use ready underscore test. Asterisk implement a reliable ready underscore test to ensure that your container is fully started before running tests. This will make your tests more reliable and prevent intermittent failures. Avoid using time.sleep, if possible. Asterisk test container lifespan. Asterisk use the scope to determine how long to keep the container up. For instance, if the system under test relies on data in the container, then scope it to session, such that the container will be up for the whole duration of the test suite. Asterisk use named volumes. Asterisk for persistent data, consider using named volumes instead of mounting host directories. This makes your tests more portable. Asterisk use parameterized tests. Asterisk use ptests parameterize feature to run the same test with different configurations or input data. Asterisk clean up resources. Asterisk ensure that all resources, example files, databases, created during the tests are properly cleaned up after the tests finish. Mayfly helps with container cleanup, but you may need to handle resources inside the containers. Complete example with a database. Asterisk. Let's create a slightly more complex example involving a web application that connects to a PostgreSQL database. 1. Update the web application. Modify AppPy to connect to a PostgreSQL database. You'll need to install the Psychopage2 library. Update requirements.txt. 2. Update the Docker file. Make sure your Docker file includes the necessary changes for the new dependencies. 3. Rebuild the image. 4. Update the test file. Update test_app.py to include the PostgreSQL container and the updated ready_test. Explanation of changes. Containers fixture. The container fixture is replaced with the containers fixture to manage both the web app and the PostgreSQL database. Web_app_config environment. We set environment variables in the web application container to point to the database. Crucially, the db_host is set to db, which is the name we gave to the database container. Docker's networking allows containers to resolve each other by name. *db_config name*. We assign the name db to the database container. This name is used in the web app's environment variables. *initialize database. Runs commands in the container to create the database objects. *check_db_connection. *custom ready_test that checks the PostgreSQL database is accepting connections before tests. Uses pg_iread command inside the container. *database version verification. *checks the database version in the result. 5. Run the test again. This test now verifies that the web application can connect to the PostgreSQL database running in a separate Docker container. Conclusion. Mayfly simplifies the process of integrating Docker into your acceptance testing workflow. By automating container management, it enables you to create reliable, repeatable, and isolated test environments, ultimately improving the quality of your software. Remember to tailor your container configurations, tests, and setup/teardown logic to the specific needs of your application and user stories. This tutorial provided a solid foundation for using Mayfly with Python and ptest. Explore the Mayfly documentation, https://github.com/dirkse/mayfly, https://github.com/dirkse/mayfly, for more advanced features and customization options. Remember that a reliable ready_test is the key to avoiding common Docker testing problems.